We're looking at another experiment to understand the rate of change of momentum. So the procedure is quite simple. Observe the spring balance when changing the velocity, thus also changing the momentum of the toy car drastically. So what is spring balance? This particular system is a spring balance. This is a spring balance. So what will it do? It helps in measuring force. How does it do that? That I'm not able to explain over here. But yeah, we need it to measure the force. When will we apply force? While pulling the toy car. So this is your toy car. So we are pulling this, obviously using a force. And this spring balance will help us measure it. We are not looking at a very specific measurement or value. We're just looking at the degree of it. So there are two scenarios. One, we are pulling the toy car drastically, and one slowly. That is, one quickly and one slowly. So we just have to observe how much compression happens. So this is where your spring is. Okay, that's where your spring is. So we need to look at how much of compression will we see. Will it get compressed a lot or little is what we have to observe. Right? So there are two variations. One, I'll be pulling it fast, and another slowly. So please have a look at it. Right? So what did we observe? In the first case, when we are pulling something drastically, there is a lot of compression. It moved from here till here. While when we are looking at a small compression, it is a small gap. The force in case of changing the momentum drastically is this, and slowly it's this. The force is a lot lesser in the second case. So here there's a huge force, there's a small force over here. That's what the spring balance is telling us. And thus the velocity here is more and here it's less comparatively. And so the momentum over here is a lot bigger than over here. Agree? P1 is more than P2. P1 is more than P2. So let me give a practical example, a bit more practical than this so that you guys can relate it. If we have to reach, say you are at rest, right? Then you want to reach 60 km per hour. So you're waiting at a signal, you're in a vehicle. If you want to reach 60 km per hour or 100 km per hour in a short duration, what happens? You need to accelerate really fast, right? So your engine makes a lot of noise and you feel a lot of force, is it not? Because we need a lot of force for a lot of change in velocity, and that is a lot of change in momentum. Or if you're doing it slowly, there's a kid, the kids are playing around, parents generally drive slowly. So there they move from rest to 60 maybe within 5-10 seconds. While if you want to do it very fast, then you have to accelerate very fast, that is apply a lot of force. Does that make sense? So basically what can we conclude? The amount of force to change the momentum drastically is dash in comparison to the amount of force to change the momentum slowly to the same value. And this dash is greater than. So to conclude, faster we need the momentum to change, greater is the force required. Does that make sense? Rate of change of momentum is proportional to force. If I increase the force, then the rate at which the momentum changes also increases. Right? Does it make sense? So again, we are coming back to the same result, that if the momentum changes fast, means there's a lot of force being applied over there. So please pause, just make a running note. Again, you need to explain things for yourself for your future self, so that when you read it, you'll get the idea over here, whatever we understood, whatever you understood, put it in words so that you are, or diagram or anything, whatever helps you in any language, doesn't matter, so that you can recall it.